Welcome. Today we're solving Leetcode problem 2169. Count operations to obtain 0. Let's break down what we're asked to do. We have two non-negative integers, num1 and num2. In each operation we compare them. If num1 is greater than or equal to num2, we subtract num2 from num1. Otherwise, we subtract num1 from num2. For example, if num1 is 5 and num2 is 4, we subtract 4 from 5, leaving num1 as 1 and num2 still 4. Our goal is to count how many operations it takes until either number becomes 0. This is essentially simulating a subtraction process repeatedly. The most straightforward solution is simulation. We simply follow the rules exactly as described. We'll use a counter starting at 0. While both num1 and num2 are not 0, we check which is larger. If num1 is greater than or equal to num2, subtract num2 from num1. Otherwise, subtract num1 from num2. After each subtraction, increment our counter. When one number reaches 0, we return the counter. This approach is simple and intuitive. The time complexity depends on the values. In the worst case, it could be O max of num1 and num2, which works fine for small inputs but might be slow for very large numbers. Here's where it gets interesting. This process is actually very similar to the Euclidean algorithm for finding the greatest common divisor. Notice that repeatedly subtracting the smaller from the larger is essentially what division does. Instead of subtracting num2 from num1 multiple times, we could divide num1 by num2 to find how many subtractions occur. For example, if num1 is 10 and num2 is 3, we'd subtract 3 from 10 3 times before num1 becomes 1. That's simply 10 divided by 3, which equals 3 with a remainder of 1. This insight leads us to an optimized solution. Using division, we can optimize dramatically. Initialize a counter to 0. While both numbers are non-zero, if num1 is greater than or equal to num2, we add num1 divided by num2 to our counter, then set num1 to num1 modulo num2. Otherwise, we add num2 divided by num1 to our counter and set num2 to num2 modulo num1. The modulo operation gives us the remainder, which is what's left after all those subtractions. Continue until one number is 0. This reduces our time complexity to O log of minimum of num1 and num2, which is significantly faster. Let's trace through an example. Say num1 is 10 and num2 is 3. First, 10 is greater than 3, so we add 10 divided by 3, which is 3 operations, to our counter. Now, num1 becomes 10 modulo 3, which equals 1. So we have counter equals 3, num1 equals 1, num2 equals 3. Next iteration, 1 is less than 3, so we add 3 divided by 1, which is 3, to our counter. Counter is now 6, and num2 becomes 0. We stop here and return 6. This matches what we'd get by simulating each subtraction manually, but much faster.